Alright, lesson 53 is adding and subtracting polynomials. So, first thing we need to know is a couple of vocabulary words. So, first word is a monomial. A monomial is the product of numbers and or variables, so it doesn't have to have both, but it can, with whole number exponents. Has to be whole numbers, so 1, 2, 3, 4, 5, on out to infinity. It can't be 0 or less. Okay, so a couple of good examples of a monomial would be just x. If you have x to the third over 2 would be an example, because it's just one term. Negative xy, 0.5 times x, or 0.75, excuse me, times x squared, or even just 3. So anything that it looks, the way I think about it is it looks like one term and all the exponents are positive. Okay? Things that are not polynomials. Here's a few examples. 1 over x, because this is the same as x to the negative 1. That makes it a negative exponent. So anything where the variable is on the bottom. Variable cannot be on the bottom. If you have x minus y, that is not the same as multiplying. It has to be a product of the numbers. So it has to be multiplying two things. Or if you just have like 0.75 times x to the negative 2, again, that's a negative exponent. So it has to have whole number exponents, has to be a product, so you have to be multiplying, and that is what makes it a monomial. Okay? So, there's that. Let's talk about the degree of a monomial. Let's make this big enough for you to read it. Okay, so the degree of a monomial. Okay. All this is the sum of the exponents of the variables in the monomial. So it's only the variables. You cannot count the exponents on a whole number. Degree of a monomial. Sum of the exponents, so sum of the exponents of the variables. Has to be variables. So let's just jump right in here with a couple examples. First example, if I have negative 7 x squared y z cubed, I'm only going to add exponents on the variables. So remember, this y is like having a little 1 up there, so I'm going to add 2 plus 1 plus 3 gives me 6. So the degree of this monomial should be 6. Okay, let's try another one here. I've got 8xy squared z. I'm going to go in and I always write in the like invisible exponents. So I put the 1 with x, I put the 1 with z, and then I do 1 plus 2 plus 1. That gives me 4. The degree of this monomial is 4. Let's do one more. I have 12 squared a b cubed c. Now, remember, the rules for finding the degree is it's the sum of the exponents only on the variables. So I can't actually use this 12 squared. It doesn't help me out at all. But I can use a to the first and c to the first and b cubed. So I'm going to do 1 plus 3 plus 1, which gets me 5. So the degree on this monomial is 5. You only add the exponents on variables. Whole numbers do not count towards the degree. Okay. Let's talk about a couple different polynomials. Polynomial just means it's a monomial or the sum of or difference of monomials. So it's like adding and subtracting them together. So there's more than one term. A polynomial with one term is called a monomial, because mono means one. If it has two terms, it is called a binomial, because bi means two, like bicycle has two wheels, binomial has two terms. Three terms is called a trinomial, because tri means three. So those are the only four we are going to do. But if you're finding the degree of a polynomial, it is the degree of the greatest term in the polynomial. So let's note that. Degree of polynomial is the degree of the greatest term. So you don't add all the terms together, you find the greatest term and find the degree, that is it. A couple other things we need to talk about with polynomials. There's a thing called a leading coefficient. Now, we've talked about coefficients in the past. Coefficients are just the numbers, the whole numbers that go in front of the variables, so like 3x. 3 is the leading coefficient. The leading coefficient for a polynomial is the coefficient of the term with the greatest degree. So you find the degree, and then that coefficient is the leading coefficient. So let's write this down. Coefficient of the term with the greatest degree. Okay, and the last little note we need to make is standard form of a polynomial. And this is where the polynomial, the terms are written in order from greatest degree to least degree. So terms in order from greatest degree to least degree. So there's a lot of different things that kind of depend on the degree of the polynomial. If you know the degree of the polynomial, you can find the leading coefficient, and you can write the polynomial in standard form. So being able to understand how to find the degree of a polynomial is going to be very important for this lesson. Okay, let's practice writing a polynomial in standard form. So for this example, my polynomial is 2n squared plus n cubed. Now remember, when we write it in standard form, the terms are in order from greatest degree to least degree. Well, let's look at the degree of each of these terms. This first term, 2n squared, the degree would be 2, because you only count the exponents on the variables, and the only one we have is 2. For n cubed, the degree would be 3. So if we're writing these in order from greatest degree to least degree, n cubed should be first, and then plus, since this is a positive 2, it'll be a plus 2n squared. And now it's in standard form. Okay, let's try another example. How about if I have 8xy squared minus 9 plus 5x cubed y cubed z. Well, if we're looking at this first term, we have x to the 1, y squared, so the degree is 3. The second term is just 9, which doesn't have any variables to count the exponents, so the degree would be 0. And this last term, 5x cubed y cubed z, I've got 3 plus 1, which would give me 7. So this is the term with the highest degree, so it should go first. 5x cubed y cubed z. Then the next highest degree would be 3, so we're going to add, because this is a positive 8, plus 8x y squared, and then last we're going to subtract 9 because it has the lowest degree. Any whole number that does not have a variable with it should always be the last thing you write in standard form. Whole numbers should come last in standard form. Okay, how about one last example just to make sure we got this. Here we go. We've got 9x squared y minus 3x squared y squared minus 5xy. So the degree of 9x squared y would be 2 plus 1 is 3. The degree of 3x squared y squared would be 2 plus 2 is 4. And the degree of 5xy would be 1 plus 1 is 2. So our highest degree is 4. So we're going to write negative 3x squared y squared first. Notice how you keep the sign with the term. So like this has a minus, we keep the minus with it. Our next highest would be 9x squared y because it had a degree of 3. This is a positive 9, so we're going to add 9x squared y. And last but not least, with a degree of 2, we've got minus 5xy. And that is in standard form. So if we go back and look at these last 3 examples, we should be able to find the leading coefficient in each of them. And remember, the leading coefficient is the coefficient of the term with the greatest degree. Well, we wrote the greatest degree first, so that should be easy to find. So in this first one, where we had n cubed plus 2 times n squared, the leading coefficient would be the number in front of n cubed, which, remember, if there's not a number, it's always 1. So in this case, the leading coefficient would be 1. Alright, in the second example, we had 5x cubed y to the third z as our greatest degree term. So the coefficient that goes with this term is 5, so the leading coefficient is 5. And this last example we just did, the highest degree was the term negative 3x squared y squared, so our leading coefficient is negative 3. Okay, the last thing we are going to learn to do today is add and subtract these polynomials. So let's start out with adding. You can only add like terms. So like terms, again, means it has to have the same variable with the same exponent. So here's our first example. We've got negative 8x cubed plus 4x squared plus x plus 1. And we are going to add 3x squared cubed minus 2x squared plus 7. Okay, so you can either just go through these and match them up, or I personally like to stack them up so it's easier for me to see the like terms. So let's try that. I've got negative 8x cubed plus 4x squared plus x plus 1. And I'm adding 3x cubed, negative 2x squared. This second polynomial doesn't have an x, so I'm going to leave that blank. And then I'm going to line the 7 up with a 1 because those are like terms. So then it's just adding and subtracting as usual. So we've got 1 plus 7 is 8, and it's a positive. If you want, you could fill in a plus 0x here, which means x plus 0x would give me still a positive x. 4x squared plus negative 2x squared would give me 2x squared, a positive 2x squared. And negative 8x cubed plus 3x cubed would give me negative 5x cubed. And there we are. Again, you could just look at it written horizontally and try to combine like terms. I just think it's easier when I stack it up so that I can see everything. Let's try another example. X plus 10 plus 2x cubed. And we're going to add 3x squared minus 7x minus 2. Okay, this first one is not written in standard form, so I'm going to put it in order as I write it down. So the highest degree would be 2x cubed, plus we don't have an x squared, so 0x squared, plus x plus 10. And we're adding 3x squared, so we need to make sure, and we are adding 3x squared, so there's no x cubed term, so we're going to fill that in with a 0, plus 3x squared, negative 7x, and negative 2. Okay, so now we can add these together. We've got 10 plus a negative 2 is a positive 8. Positive 1x plus a negative 7x is a negative 6x. 0x squared plus 3x squared is positive 3x squared. And 2x cubed plus 0x cubed is still positive 2x cubed. And that is how you add them together. Okay, the last thing we need to do today, I know this is kind of a longer video, but there's a lot of information. This is the last thing we're going to do is subtracting polynomials. So subtract. Subtracting works the same way as adding. You have to have like terms. It's just that instead of adding them together, we're going to subtract them. So let's jump into an example. We've got 6x squared plus 4x plus 2, and we are going to subtract the polynomial 2x squared minus x plus 8. Okay, again, you could look at it horizontally and try to combine like terms. I like to stack them up, so I'm going to stick to that. I think it's easier to see. So we've got 6x squared plus 4x plus 2, and we are subtracting 2x squared, negative x, and 8. Okay, so 2 minus 8 is negative 6. 4x minus negative x, this turns into a plus a positive, so 4x plus 1x is 5x, positive 5x, and then 6x squared minus 2x squared is 4x squared. So with subtracting, you really have to be careful when those negatives turn into positives and what you're doing there. Let's try one more example, and then we will call it a day. I've got x squared plus 4x minus 9. And we are going to subtract 4x squared minus 5x plus 11. So stack them up. We've got x squared plus 4x minus 9. And we're subtracting 4x squared negative 5x positive 11. So negative 9 minus 11 gives us negative 20. Positive 4x minus negative 5x makes it 4x plus 5x, which gives us 9x. And x squared minus 4x squared is negative 3x squared. Okay, so remember, you have to have like terms. You want to try to write it in standard form when you get done. For these, they've been working out really well. There was that one example where we had to put them in order before we started solving. But overall, the key is just to remember you have to find like terms, and then you can add and subtract those from each other. Alright, you should have all the information you need to go ahead and try the work, and I will see you in class.